So hello everyone, today we will be covering the learning objective 3 of mechanics, which is to understand the energy transfer, forces and elasticity. So in this session, we will be covering calculation of the energy transfer involved when work is done, conversion between Newton meters and joules, and then examples of forces involved in stretching, bending or compressing an object, and the difference between elastic deformation and inelastic deformation caused by stretching forces. So the first one is to calculate the energy transfer involved when work is done. So when work is done, it is measured by the formula work done is equal to force into distance. So where W is equal to the work done, which is measured in joules, F is the force applied in newtons, S is the distance over which the force is applied in meters. So this is the formula which shows the relationship between work done and uh, between Newton meter and the joules. So let us understand this with an example. So if you have a force of 90 newtons applied to move an object along a straight path for a distance of 10 meters, then you have a force of 90 newton and distance is equal to 10 meters. So the calculations of work done is equal to force into distance by applying the formula. So W is equal to 50 newtons into 10 meter, which is 500 joules. So the work done in this case is 500 joules. So this represents the energy transfer involved when the force of 50 newtons is applied to move the object over the distance of 10 meters. So this basically represents the energy transfer. So next we look into the conversion of joule in Newton meter. So joule is basically the energy involved, and as we studied in the previous slide, it is force into the distance covered. So force is measured in Newton and distance covered is measured in meter. So the conversion of the joule is Newton into Newton multiplied by meter. So these two units measure the same quantity, which is the energy transfer or the work done. So you can use them interchangeably in calculations of energy. So you can convert 1 joule is equal to 1 Newton multiplied by 1 meter, or the Newton will be equal to 1 joule divided by 1 meter. So that is the interchangeable relationship that you can use. So next we look into the examples of the forces involved in stretching, bending or compressing an object. So the first one is stretching an elastic spring. So if you remember in our last session, we had covered potential energy, kinetic energy, the energy stored in an elastic spring. So those features we had covered in our last session. So here we will cover.
Sanjay.
Yes.
Sorry to interrupt you. I only joined up at the end of last week, and I haven't done my induction or the previous sessions or anything like that. So I'm not too sure that I'm in the correct Zoom meeting.
So what you can do is, I will just speak to the course coordinator. You can go through the previous sessions recordings which are available. So you can go through, so all these sessions are being recorded. So in the previous 2 sessions, you can go through them. Those have been recorded. And if you have any doubts, you can always reach out to me.
Okay, is that okay? Okay. I think I'm going to just exit the Zoom meeting because I think the other guy I'm in contact with that I still need to do my induction with.
Okay.
Will be happening tomorrow. So then I can at least backtrack on the recordings and then join up again as soon as possible.
Sure, not a problem. That you can do.
Okay.
That. Sure. Okay.
Okay. Thank you very much. Thank you very much. Thank you very much. Have a good evening.
Thank you. Thank you. So we continue with our session, which is stretching an elastic spring.
You know, the past, which is this LO3?
This is LO3, that's right.
This is LO3. You know, LO1 and LO2, the recordings for that, are they on the website or on the WhatsApp
Yeah.
group chat?
Yeah, they are there on the LMS also.
They're on both.
Yes.
Because I wasn't there for that, so I'll watch that after.
Okay. So we can continue with this session, right?
Yeah.
Okay. So stretching and elastic spring. So when you stretch an elastic spring, you apply a force that tries to return the spring to its equilibrium position. So basically, when a spring is stretched and when it is left, so it comes back to its original position. So it is described by the uh, it is described by the Hooke's law, which explains the relationship between force, the spring constant, and the extension. So where F is the force applied in newtons, K is the spring constant in newtons per meter, and E is the extension in meter. So, for example, if you're stretching a rubber band, the more you stretch, the greater the force needed to stretch it further. So, force is equal to the elastic constant into it is the spring constant into extension. So that is the equation of the Hooke's law, which describes the relationship between force and the extension. Then another case is that of bending a beam. So when you bend a beam or a plank, you apply a force that tries to change its shape. So here, the equation of Hooke's law can also be applied, but it is not a linear relationship. So the force required to bend a beam depends on various factors, including the material properties such as tensile strength of the beam, the geometry, the inclination. So, but there are different equations which is used in advanced physics such as theory of materials, where you apply different types of forces. So since there is no linear relationship, it cannot be described using a single formula. So it depends on different situations. So engineers use equations such as bending moment formula to calculate the forces involved in bending beams. So an example could be bending a wooden plank or metal beam in construction or engineering applications. So next one is compressing an elastic object. So when you compress an elastic object like a spring, so you apply a force that tries to push it back to its equilibrium position, and the spring also it applies the force in the opposite direction. So similar to the stretching, the Hooke's law can also be applied for compression, which is F is equal to K into E. Here F is the compression force, K is the spring constant, and E is the compression. So it is the same, the extension, the equation for extension, it also holds for equation for compression. So for example, compressing a coil spring in a car suspension system. So the more you compress it, the greater the force pushing it back. So next we look into the difference between elastic deformation and inelastic deformation caused by stretching forces. So in elastic deformation, you observe a reversible behavior. So in this case, the elastic deformation, it occurs when a material responds to a stretching force by changing its shape, but returns to its original shape and size when the force is removed. But in an irreversible behavior, which is inelastic deformation, in that case, the material, when it is stretched by a force, it doesn't return to its original shape and size when the force is removed. So instead it undergoes a permanent change in either its shape or its size. So that is the characteristic of inelastic deformation. Then we have Hooke's law. So in case of elastic deformation, whether it is extension or compression, so the Hooke's law, which is the linear relationship between the applied force and the resulting deformation, that equation is explained by Hooke's law. So that means that the stress is directly proportional to strain within the elastic limit of the material. So that is the so in elastic deformation, you simply have to remember that the Hooke's law it holds, which means that the linear relationship between the force and deformation is explained in elastic deformation. But in inelastic deformation, there is no linear stress and strain relationship. So the material may exhibit plastic behavior, which means that it may undergo permanent change in shape even under relatively small forces. So that is the characteristic of inelastic deformation. Then the third one is energy storage. So when a material undergoes elastic deformation, it stores potential energy as it is stressed. So this potential energy is converted into kinetic energy as the material returns to its original shape when the force is released. So basically the conversion of energy from potential energy to kinetic energy, it happens in an elastic deformation. But in an inelastic deformation, it involves dissipation of energy where there is some kind of energy loss. So this is why the materials undergoing inelastic deformation, they become warm or exhibit changes in their physical properties. So you don't have full energy storage in the case of inelastic deformation. So there is energy dissipation in the form of heat or any other internal energy within the material. So next we look into the examples of elastic deformation and inelastic deformation. So in the case of elastic deformation, the examples include rubber bands, steel springs, and most metals. So these materials can stretch under force and return to the initial state when the force is released. Whereas materials like clay, putty, and some other type of plastics are known for undergoing inelastic deformation. So in general engineering, inelastic deformation is undesirable because it leads to permanent change in shape and properties. So simple way to remember is that an elastic deformation, it returns to its original shape and size, it converts the energy and from one form into another, and there is no energy loss. So the common examples include steel springs and rubber bands and most metals. But in the case of inelastic deformation, there is always some form of energy dissipation, for example, in the form of heat, and then the object, they do not return back to their original shape and size. So this is how you characterize or differentiate between elastic and inelastic deformation. So the main summary is that the main difference between elastic and inelastic deformation is the material's ability to recover its original shape. So in elastic deformation, the material returns to its initial state, while in inelastic deformation, the material undergoes permanent change and often dissipates energy in the process. So this is the basic summarized version. So with this, we conclude the session of mechanics. So in the next session, we will be discussing the assignment, like how you are going to proceed with the assignments. In case if you have any questions, you can let me know.
Okay. Thank you.
Thank you.